third one. That is, if the plane cuts all the three axes. All the three axes. Follow this point now. Now here also, this is sigma 1, sigma 2, sigma 3, this is sigma 2 now. Here the three cases cannot arise, now only one case now, cutting all the three axes. All the three axes. वहाँ three case क्योंकि there are options. Here there is only one case now, cutting all three axes. So what he says, the angle he is taking, this is the pole. Remember, because these conventions are sometimes people remember it. There theta you are measuring with the plane. Also with pole you can measure. Two options are there, Here I am only giving you one option. The angle between this axis and the pole. थोड़ा convention of याद करना. इसका मतलब है the pole with respect to sigma 1 angle is A. Pole with respect to sigma 2 B. Pole with respect to sigma 3 C. These are the angles in degrees. In degree only. Now he is bringing L, M, N, These are all Pythagoras theorems, nothing great. Cos of A, cos of B, cos of C. Pole angle के साथ. Understand what is L, M, N? Now he is writing the formula. Just I will take it from my note. So what he writes, A square plus sigma 2 m square plus sigma 3 n square. This is normal stress and shear stress का स्क्वायर निकलता है. टाउ स्क्वायर सिग्मा 1 माइनस सिग्मा 2 स्क्वायर into n square m square plus sigma 2 minus sigma 3 square m square n square plus sigma 3 minus sigma 1 square n square n square. Very easy formula, कोई problem नहीं. This is the shear stress this plane will experience. This is the normal stress this plane will experience. Follow this point. So what he is asking, you compare this tau and this tau. Which is greater? That is the thing, na? See, you can take some values. This you test today. Because now just looking at this you cannot say. I will give you a physical meaning to this formula. But if you put some values, na, sigma 1 some values, sigma 3 some values, and this theta some values. Similarly, you will explore this one. You will find, this value is greater than this value. Understand this. What he says, the shear stress experienced by a plane, if it cuts all the three axes, can never be more than if that plane cuts only sigma 1 and sigma 3 axis. That is the conclusion. अब तीनों को काट दिया तो उसमें जितना shear stress होगा, it can never exceed this value. You can try taking some values. You can try. Now, this L clearly na ABC, ABC. These are the angles, 30 degree, 40 degree, 50 degree. Cos of these values is 11. Suppose A is equal to 30 degree, B is equal to 40. ये कितना होगा? I'm just asking. Suppose A means this angle, A. B means this angle. C means this angle. C means this one. A is equal to 30, B is equal to 40. C कितना होगा? हाँ? बोल पाओगे? नहीं बोल पाओगे। ये आप कितना बार उसका भूल गया। स्कूल के सब्जेक्ट भूल गया। मैं एक क्लू देता हूँ। हाँ? Will it be total 180 degree? Total 360 degree? No. Then what is the relation between them? A, B, C में क्या relationship है? नहीं याद है ना? मालूम है बाकी याद नहीं है। मेरे को भी याद नहीं है। See what he says, values are such, m square plus m square plus n square is equal to ये उसका condition. The angles will be such, their cos values will sum up to 1. So accordingly you fix some values. क्या आप लोगे this values, then this will become 1. Then you test. So whatever results you will get in tau, it can never exceed this value. समझे कि मेरा बात नहीं समझा बताओ. So this is the guiding. What should be the angle? And suppose in this case I am telling, it just cuts two axes. If this is 30 degree, you are telling how much it is? 69. So what is the relationship between them? 90 minus 1 ठीक है. यही है ना sin square theta plus cos square theta is equal to 1 ना. इसलिए तो ये 30-60 होता है ना. यही ना, this is the principle ना, sin square theta plus cos square theta is 1. Similarly for this is the rule. Cos square A, cos square B, cos square C is equal to 1. Should try. ठीक है ना? हाँ, करके इसको देखो, ये वैल्यू will never exceed than this. समझा ना? These three categories. So if I ask this question to you, suppose the regular body you are taking like this, sigma 1, this is sigma 3, this is sigma 2. This is the thing now. So rock will break here. There are thousands of planes. Plane cutting all the 3 axes, plane cutting only 1 axis, plane cutting only 2 axes. All those planes are possible. But which plane is vulnerable to a failure? One which is cutting sigma 1 and sigma 3. No other plane will break. Would you follow this point now? Why rock breaks here only? This is the reason. Rocks दूसरा जगह में कभी नहीं टूटे. Only the plane which is making sigma 1, sigma 3 ऐसे ही कट करता है. Along that plane it will only break. Other plane it will not break because they are not experiencing maximum shear strain or shear stress, sorry, not strain. हाँ, ठीक है ना? Up to this, no doubt. So next question what I am asking, so this is the shear stress ना? No problem ना? So theta is this angle, right? We are taking theta is this angle. ठीक है ना? Now this plane could be like this, ना? Any orientation, any theta can be taken. So where maximum shear stress takes place then?
45.
With all these orientations, if theta is 45 degree, maximum shear stress will take place. Even if it cuts two axes, but one which is at 45 degree angle, their maximum shear stress is taken. So that is a vulnerable plane. Perfect. Understood? Huh? You see? So specific. I will only break here. But when you break a rock, now you don't experience these things, nor realize these things. But it happens. It happens. Many times during earthquake, you will see cracks developing on the wall, you know, at an angle to the wall boundaries. Reason is this. Reason is this. Where it experiences maximum shear stress, the rock will break. Understood this part up to this point? Now, point is, when Moore carried out this experiment, you know, he found the fractures are developing at 30 degree angle, you know. With sigma 1, it is developing at 30 degree angle, not at 45 degree angle. So, as per this formula, it should break at 45, but he found instead of 45, it breaks at 30 degree. Understood ना? But 30 degree में maximum shear stress नहीं होता है. This is his observation. What he observed? Instead rock breaks at 30 degree. To follow this point, na? So then he gave this explanation. This Moore, Coulomb, Navier. Why rock breaks at 30 degree? 30 degree में तो maximum shear stress नहीं होगा ना. If you put 30 degree here, the value you will get, and if you put 45 degree here, value will be more. This is the reference. He observed 30 degree point, the maximum, the fracturing is taking place, though there is no maximum shear stress. So how does it look like, you know? I'll just tell you. In a 2 dimension, if you draw the diagram, you know, instead of, this is 45 degree angle. This is 30 degree angle. See? Here is the maximum shear stress. Tau is maximum here. Here it is not maximum, but rock is breaking. But reason then, why it happens so? Though maximum shear stress is not there. Would you follow this point now? So explanation he gave, you know. Now, it is maximum shear stress is taking place here. But now when you are breaking the rock, you know, you have to displace it, no? Otherwise break करके क्या फायदा? आप खाली ऐसे break नहीं कर पाएंगे. Unless you displace this thing, then this breaking will not happen. Remember. If you allow to displace, then only the fracture will develop. ऐसे crack develop करके नहीं रहेगा. उसको displace करना पड़ेगा. So when this breaking or failure and displacement, they are failure and displacement. ये होना ही होना है. To follow this point, na. So if you are breaking the rock here, you should also create a displacement. So पहले ये थोड़ा ऐसे हो जाना चाहिए. मालूम है ना? ऐसे हो जाना चाहिए. Break भी करेगा. Simultaneously, it should also displace. If you are not displacing, it will not break. It will not break. Understood, na? Now, for displacing the things, you know, 2 things comes into picture. 2 things. One is the cohesion, another is the friction. So, when you are displacing one block with the other, so this cohesion, you know, cohesion means the grains. They are coming into picture, you know. One is other side grains are coming, quartz, feldspar, say. They are all interlocking like this, na? Interlocking like this. When you are breaking it, this bond has to be broken, you know. This cohesion has to be broken up. So cohesion will oppose. I will definitely allow but you first break the cohesion. Break the cohesion means you apply such a strength, so that the cohesion will break. 45 डिग्री में बहुत shear stress हो गया तो क्या हो गया? आप तो cohesion तोड़ नहीं पा रहे हैं. That is it. Similarly, when you are displacing a block, this is applying some amount of friction. Even if the grains are, there is no projection of the grains, but a friction will be there. इसका जो weight है ना, इसका weight है. आप देखो, आप slide में जब खेलते हैं, वही plane, when plane becomes like this, you start sliding. But when it is like this, you are not sliding, ना. तो क्या, what factor plays the role? It is the friction, not cohesion. Cohesion इधर भी जितना है, इधर भी उतना है. But because of the slope, some here you are getting maximum because of the load. Your weight, that is creating friction. If it is less angle, friction becomes less. If it is more angle, so 45 degree angle and 30 degree angle, if you compare, 30 degree will have minimum friction. ना? उससे भी आगे जाएगा तो और भी कम होगा, but we don't need it. आप जो स्लाइड में खेलते हैं, स्लाइड के जो एंगल रखते हैं, it is just sufficient, so that you can slide. वर्टिकल कर देगा तो क्या होगा? तो गिर ही जाओगे, आप खेलोगे कैसे? But you require minimum angle where you can slide. That is the thing. What is the minimum? You just go here. It is your slide angle is like this. You are not sliding. But you go a little increase. The moment it starts sliding, that is the angle. Why you want to increase further? You don't understand, na? So this 30 degree position is a place where the sliding takes place. Friction becomes under control. Friction becomes minimum there. उससे आगे बढ़ाने से friction कम होगा, but you don't need it. You don't need it. इधर ही slide करने लगे. You don't understand, na? So that means two factors. One is your strength, your applying stress should be such, जिसको काट के निकाल देगा एकदम घिसके. तो कोहेशन तो तोड़ दें. आप जो 20 पहले जो ब्रेक कर रहे थे आप, रिमेम्बर पहले जो ब्रेक 25 में ब्रेक नहीं किया, 35 में रॉक ब्रेक. So 25, though it is very high, but it is unable to commit. कोहेशन को तोड़ नहीं सकता. Similarly, because you apply such a stress, so that all these projections will be smoothened down. Remember, that is called breaking the cohesion. Cohesion who gives this kind of things, small projections. What gives friction? This weight, ऊपर का weight. So friction is provided by this overlying weight. Cohesion is given by these projections. तो अब ये दोनों को overcome करेगा, तभी जाके rock will break. It is not just at 45 degree position, because you are having maximum shear stress, rock will break. So that is the reason why rock does not break at 45 degree. Rock breaks at 30 degree. Answer you could understand, na? One is your at 30 degree position, the friction will be the minimum. It will be overcome, and cohesion will be under control. So these are the two things, that is required for rock to fail. Because failure means there should be displacement. खाली ऐसे क्रैक हो गया वो failure नहीं. वो भी है provided to given displacement, then only they will develop. अब देखो अभी यहाँ only to give a small displacement, the crack will not develop even. अब थोड़ा याद रखो. So far no problem ना. कुछ doubt है क्या? हाँ? So that means that is why the rock is breaking at 30 degrees. So now what we understood? We understood if a plane is cutting all the three axes, it will not fail. It will only fail if it is sigma 1 and sigma 3, minimum 1 and maximum 1 it cuts. At what angle? 30 degree. This is what we have studied. And the same thing he is telling from the graph. Graph से कर रहा है. ये समझो. ग्राफ थोड़ा पढ़ने के लिए थोड़ा you should learn some basic also. Now the graph is plotted between a normal stress and the shear stress. Shear stress. Understood now?